Test. Is the mic on? I think it is, right. All right, let's start the video. Hello, y'all. Hello, everyone. My name is Putu Surya Arsuka. You can call me Gesa. And in this video, I am going to explain the code that goes behind the making of the game Tetris. I want to preface this project by saying that first of all, this project is for my finals project of algorithm and programming, and this is my finals project. And second of all, I reference this code entirely on freecodecamp.org on their YouTube channel and their pastebin or rather GitHub source code. So some of the things that you see here may be a lot similar than the one that is on their YouTube channel, because it is exactly that. I only changed a few things such as their fonts used, the window width and the window height and the play, etc. etc. It's only a little of what they make. It's only the minor things that I've changed. So let's get on to the code itself. First of all, before I try to explain what the code does or what the functions are and what the class and attributes are, I want to show the demo of the game when it's being played. Okay, as you can see here, this is the gameplay screen. This is the window of the screen that we're going to play. And press any key to begin. We can press any key on our keyboard, and we can press escape to exit the game of Tetris in here. So let's just start by pressing the space bar. And as you can see here, there are blocks that are falling from the top of our play area. So yeah, this is the game itself, the game of Tetris itself. Let's just quickly try to get a game over here so that I can move on to the explanation. Okay, let's see here. Now, this is the screen when we get a game over, which is a simple "you lost" prompt that is being displayed on the screen. All right, let's move on to the explanation of how the game works. First of all, we have two modules here that we're going to import, which is the random and PyGame library. Random is a built-in Python library, and it's used mainly to randomize certain variables. And there are PyGame library, which are the library that's used in Python making games. So the first line here, in the fourth line of the code here, there is pygame.font.init. It's mainly used as an initialization function to get the fonts that we're going to use in our game. Second, let's talk about the global variables. We have a lot of global variables here. Well, not a lot, but not very little, right? Because we have the column, the row, window width or screen width, the screen height, the play width, play height, block size, top left, etc. etc. Let me try to explain one by one. Column and row represent the column and rows that we're going to use in our gameplay area, in our box or grid that is going to be the place for the blocks to fall into or to lock their place into. So this means that the block itself is going to be possible by a 20 by 10, 10 by 20 rectangle or a 10 by 20 grid. This screen width and screen height is all of the black screen that I'm going to show here. This is going to be the screen width, and the screen height. So I hope that makes sense. And the block size is just the play width and the play height divided by the column and the rows, which is probably going to be 30 because we want the blocks to be squares, right? Also, let me explain about this top left x and top left y. Essentially, what this means is just the variable of where our x and y axes start from for our play grid. Let me try to explain it in this game form. All right, this is the so if we're trying to speak about the x and y axis, this is the x axis and this is the y axis, and the top left x is going to be this and top left y is going to be this. So yeah, that's pretty much what the top left x and top left y represents. This file path, font path, and font path game on is just essentially to establish from my folder here that we have a lot of fonts, and we're going to choose which fonts that is going to represent our variables on the screen. Now, moving on to the shapes formats, or you may be wondering, how can we convert this shape of this list of dots and zeros into the shape of blocks? I'm going to get into that in just a second, but I'm going to explain why we use lists here. The reason why I chose lists, amongst other things, is because, first of all, the YouTube video explained it in a very simpler terms using this dots and zeros. There are other method of doing this, such as using an array or a matrix, but I chose to use the most simple one out of them all, which is this type of list. So let's just remember and that there are two lists inside this S. You may be wondering why there are two lists inside the list of the shape S, Z, and etc. It's because when we try to rotate S, right, the S has a shape like this. If we rotate it 90 degrees, it's going to come up as a thunder-like shape like this. It's the same as the Z shape and the I shape. And this is going to come into play in the rotating function that I'm going to explain later on. Let's just try to remember that we have all of these shapes. Yeah, that's pretty much it. J has 4 because J, if we try to rotate J, it's going to be first like this L shape, this upside down L shape, this R shape, this backwards R shape, and then J. This is going to be rotated, right? Because if you rotate it once, it's going to be this, and that. Same as L, same as Y. Now let's move on to the shapes and shape colors list. Shapes list is just the list of all the possible shapes that we have that we've established before. And shapes colors is just representing the colors of the corresponding index of the shapes that we have. For instance, in the 0th index or the first index of shapes, we'll have the color of the first index or the 0th index in the shape colors list also. So S will have the color of green because it represents this 0, 255 and 0 represents the red, green, and blue color that are going to be established in the PyGame. Okay, let's move on to the piece itself. And I've already mentioned before that the shape itself is not this, but it's going to convert itself as this. This class piece object only have an init function because it's just to represent the attributes of which position in the x-axis and the y-axis of our play grid it's going to be, and the shape that we're going to have from the shapes list that we've established before. So it has the attribute of x, y, shapes, and shape colors using the shape index and its corresponding index, and also the rotation, which is set to be 0 because we're trying to, if we press, for instance, if we press the up key, it's going to increase by 1, by 2, by 3, by 4, by 5, and so on and so forth. That it's going to how do I say it? It's going to scroll over the items of the list, for instance, and it's going to come into place in the convert shape format piece here in the function of the convert shape format piece here. I'm going to explain this now. For just oh yeah, before that, I want to preface this also by saying that all of these functions are not in an orderly manner. And I have a chart here to explain it in an orderly manner. So I may be going to see my charts from time to time. And the pieced objects I've already mentioned, we have the rotation, right? And this convert shape format piece is essentially to change the list of shapes that we've established as dots and zeros into the block that are in the play grid area. So, hello, test, 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 test. Hello again. I'm sorry for the disturbance of the video. I forgot to mention the part where I fulfilled the criteria of the finals report. So let's just go through it in a quick second here. For the first criteria of looping, we can see on the video that I've used or that we've used a lot of looping for the detection and etc. Detection of the block and many more. But for the simplest looping that I could find is that here for the convert shape format, we're going to loop through the list of strings that we've established as shapes here by using a for loop, which has I and line, I for the index, line for the strings, and we're going to nest another for loop to detect if from those set of strings, do we have 0 to represent a block or a piece block. So this is one of the criteria being fulfilled. And let's go to the next one, which is conditional. Also, this fulfills to a certain extent, but I'm going to use another example, which is the main window of the game, where this is all of it. This is the conditional for the whether or not we press the up arrow key, down arrow key, left arrow key, and it's going to have different functions. If we press anything other than escape key when playing the game, we're going to have to have different functions. Okay, for the first function is to when we press key left or the left arrow key, we're going to move the piece to the left by 1. Move the piece to the left by 1. Move the block to the left of the grid by 1. If we press right, it's going to move it by 1 to the right, and if we press down, it's going to move one block faster to the bottom of the play grid. We press the up arrow key, it's going to rotate the piece using the function that I've already explained on the video. And that's the conditional criteria being fulfilled. The error handling is on the checking if row is fulfilled or not. And it's done by this. This is essentially if I'm talking in simpler terms that I could understand myself. We're trying to catch the values that are in the lock positions dictionary that has a certain color, which is black here. If it's black, it's going to catch it and it's going to delete every key and value of the dictionary. And if it does have a value or key other than colors and XY for the valid space of the grid, it's going to just continue and not delete the row itself. So that's pretty much it. For the error handling, for the GUI, of course, it's going to be on the window or the main window. It's going to be this one. For the draw window function, it's going to draw our surface for the game. It's going to make our canvas of the game. We're going to use blit also of the PyGame function and to draw certain labels and certain fonts. And so that's pretty much the criteria being fulfilled. Oh, and I forgot to mention, there is also an additional criteria, which is file writing and reading, which is on the score function for the get max score. Get max score here. These two functions essentially reads the high score data of another text file and access it to get a certain type of data that we can access as the high score for this game. So that's pretty much the criteria, and I hope it fulfills my grade very well. Test. Oh, I'm sorry. There was a slight microphone technical problems, but let's continue on with the piece. Okay. In this piece, we have the rotation, right? And this rotation is going to increase if we press the up key. And how does the mechanism for the rotation equals 0 to rotation equals 1 affect the kind of shape that we want? Well, here in this def function of converge shape format, we have the shape format variable, which is piece.shape, which just means to get the shape that we have right now, and it's going to rotate it. It's going to search for the index of the shape itself by searching for the rotation value and modulo divided it by the length of the piece shape itself. So for instance, if you have here the S shape, it probably has two, right? To list two possible shapes, which are S and the upside and the thunder-like shape. So it most definitely has two lengths of this shape itself. So when we increase the rotation, for instance, if it's 0, it's going to have the modulo of 0. So it's going to show us the 0th index, which is in this case the S shape index, and it's going to access that. And if we have the value of the rotation is going to be 3 or 4. If we press the up key 4 times, it's going to be divided by this length, which is 2. 3 by 2, we get a remainder of 1, which is in the index of the shapes itself. It's going to be the 1 index, which means it's going to be the second list, right? It's the second shape of the list. Hopefully that makes sense. If not, I can kind of like imagine it this way. Let's scroll up to the shapes formats. Okay, there's 2, right? If we have the original count of rotation, which is 0, it's going to access this, which is the 0th index. If we have the if we have the value of rotation set to be 1, we're going to access the first index, which is the 1 index. And if we have 2, 3, which is if 2 is divided by the length of this, which is 2, we would not get any remainder, which would equal to 0. And in this list, 0th index means the first shape, right? And hopefully that makes sense and clears up the misunderstanding. And that's about the convert shape format. Oh yeah, also there is this function, which basically means it reads the dots and zeros as a valid space to be put on the grid itself. And in this first line of for loop is for I line in the enumerate shape format. It's essentially going to number these rows of dots and zeros into 1, 2, 3, 4, 5. It's going to number it like so, and the numbers is going to be the index of the row that we're going to have. Now moving on to this next for loop, which is for J column and enumerate row. It's going to read for the column or each of the dots and zeros that are present in these list of strings, I mean. and it's going to detect if it has a 0, then it's going to add the position in the 0 to the uh, to the to the what how can I say to the coordinates of the piece itself, which is why we call for the piece.x attribute and add for the j itself, because for instance, this we have 1 2 3 from the column, right? Column number 3 is going to add this to the position of the piece itself. So so the x is going to be 3 now, and also it's also going to affect the y itself by increasing the I and the number of row index. I hope that makes sense. I know that I can't explain it properly, but the complete explanation of this code is going to be on the YouTube channel of their free code camp. I'm trying to explain it in the way that I can. So let's just move on. And the next for loop is for IPOs in enumerated positions. I couldn't quite understand this by watching their YouTube video, but what I could understand is that it essentially just offsets the block so that it doesn't produce an error, because we have this grid, right? Grid which we play our Tetris in, and essentially why we want to offset it is because if we don't, it's going to fall from a unvalid space, which is going to result in an error. So I hope it makes sense. I know I don't understand it, but I'm trying to explain it in the way that I can. And we're going to return the positions as a list here. So let's move on to the create grid function first, because it correlates directly into the piece. In the create grid function, we have this locked position, which is in the form of a dictionary, and we want to establish the grid right first. The grid is going to be made by black painted, I guess, and it's going to be 0 0 0 for black, and it's going to scan for x in range of the column that we have established before, and for y in the range of row, which is 20 and the global variable before. And this is essentially going to draw our grid, or I mean create our grid, so that we have a working play space to work with. Now let's move on to the for y in range row, and etc. This is essentially trying to map the positions of x and y that I've explained before into a dictionary that has its own color, which is black, right? Because if it doesn't have any shapes to begin, if it doesn't have any blocks that it's going in a locked position, is going to have a black color in it, right? Now, this is why it's going to be mapped in such a way for y in range row, for x in range column. And if xy in locked positions, color equals locked positions xy, it just means to get the value of the color from each of the x and y that are in our grid that we've established before. If it's empty, or if it's an empty block, or if it's an empty spot, it's going to have a 0 0, and it's going to be mapped by the xy. This is what I'm talking about. Grid y x equals color. It's going to map directly into the grid dictionary that we have here. I mean the grid list that we have here that is mapped directly into locked positions here locked pos xy here, and we're going to return the value of the grid, and that's this function. Now let's get to the get shape. Get shape is the one of the most used function in this program. Let me try to search it here. Nope, not this. Oh, this function, it's just one line of function. It basically chooses from the list of shapes that we have here earlier. It's going to randomize the choice of shapes that we get either for our current piece and our next piece. It's going to interchange and correlate beautifully in the main window that I'm going to explain later on. Now let's move on to the um, grid making. I've explained before that we already made a grid to work with, right? And this grid is going to be our play area. So let's try to draw the grid itself, which I actually have here in this program called the def draw grid, if I'm not mistaken. Yes, this is the function. Wait. Yep, this is it. This is the draw grid surface, and it's going to draw our grid for us, which is going to be black, right? I've already said it before. This is going to have the color of black because RGB equals 0, RGB equals 0. For I in range row, this is just to make it clear so that there are square spots in our grid for our blocks to fall into place with. And the code is represented by this for I in range row, PyGame.draw line, surface grid color. I don't understand this, to be honest with you, but essentially it's going to draw it for us. I've tried to follow along the YouTube tutorial, and this is all I can manage with. So yeah, I hope that amounts to something. And let's move on to the 4J in range call. Essentially, what these for loops are for is to draw the horizontal lines and the vertical lines in each row and each column so that it's clear to what space of the block it goes into. Let's try to run the game so that it's clear. Here it's faint, but you can see the gray color in here. I know in the video it might not be seen clearly, but in here maybe it's just the lighting, I guess, so that it can't be seen. So yeah, that essentially made it so that the columns and rows of the blocks are clear. So let's move on to the drawing of the play area itself, which is the draw rectangle by game.draw. Now this is what's going to be our border for our game, which is white, right? Because 255 to 55 is just white. And it's going to draw the board for us with this function of PyGame, each with their surface, border, color. I know this variable or parameter seems alien because I haven't explained it. It's because this surface border color is established in the window section of the function, which I couldn't quite understand 100% totally. I understand some bits of it, but I couldn't understand the variables that are used for the parameters. Okay, now that's all about the drawing of the grid and establishing the grid. Oh yeah, I forgot to mention that the most important thing is that we have a canvas to work with, right? In this screen, we have this square of Tetris, right? All this black space, and it's made by using the PyGame function of blit, surface.blit, if I'm not mistaken. I got that from Stack Overflow, but I could not verify if it's true. But I tried it in a separate file here in the Stack Overflow hint, and it works. It works that as intended. Let's just search it here. Surface.blit. This. Well, no, not that. Not this either. What is it? This is it. This is the surface split that is going to be our window, our first black screen window if we are going to make a game or a program with a working GUI. We're going to use surface.blit. So yeah, that's pretty much it. And let's move on to the draw next shape, or getting our next shape, which is the function of next draw next shape. Here we can find the function of the draw next shape with the parameters of piece and surface. Piece and surface is already established. Piece is I already explained it. Surface, I haven't explained it because it's on the function of window. And let's go through the function here. First, we have font initialization, and what font we're going to use. Font path is just this font that I have on my folders. Label equals font.render is just going to make the text that is going to be on our next shape's prompt, right? Because we want it to be as clear as possible. Next shape equals next shape comma 1 comma white. This one is just to, I guess it's to change the size of the text, and the text itself is going to be positioned using this variable, right? We have to establish this variable first, start x and start y. And shape format is called here because we want to get another shape, right, on top of the shape that we already have before, or our current piece. The shape format is going to be our next shape, and it's going to be almost the same as the first shape for convert shape format, but it's going to differ in in a sense that it's going to just be present in the next shape instead of the falling blocks that we have currently. So it's just going to be a display instead of a working falling block. And it has a code like this. I can't explain it in detail about what this does because I couldn't quite properly understand it myself. But it's just a condition for line enumerate shape format. It's just the same as converting these dots and zeros into valid square spaces, and the J column in enumerate row is also the same. PyGame draw rect surface blah 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 blah. It's just to draw the shape in the next shape. I hope that makes sense. And surface split dot label start x start y is just to draw our font of next shape into the position of start x and start y. Okay, that's all about the draw next shape. Let's move on to the drawing the text the middle text that we saw earlier when we're starting the game. When we're starting the game like this, press any key to begin. Let's try to learn about that. And that is possible through the function of draw text middle. This function. This draw text middle is actually inside of this draw text middle is actually a function that is going to be inside the main window because it's going to be our starting screen, right? But let's just establish it first. Draw text middle consists of 4 parameters, which is text, size, color, and surface, which is pretty clear, right? Because we want a text that has size, that has color, and it sits on a surface. First, we have to initialize the font for the PyGame. Actually, I already did it in the first. This doesn't need to be done, but to prevent error, I think I do need to use this. And now let's make the font itself. Let's establish the font as PyGame to read the font with the file path of font path, which is this gameover.ttf. And it will have the size of this, which is 50, and it's not going to be bold, and it's going to be italic, if that makes sense. And the label itself, this is just to uh, establish that what what text we're going to input in our draw text middle function here. And the surface split is just to put our text in the canvas or the screen that we have established as a black screen. In this case, it's only a black screen before we draw the text, right? And surface.split just puts it there. So I hope that makes sense. All right, that's all about the grid. I hope that provides some sort of explanation, and let's move on to the gameplay itself. Let's start with valid space, or checking if the space of the grid is a valid space. Valid space. I'm sorry. It's going to be butchered, so no. This function of valid space is essentially used to check if the square of the function, I mean not the square of the function, the square of the Tetris block is in a valid spot or not, or in simpler terms, does it go there, right? Because we need a function to check if our block so that it doesn't fall out of the play area. And this valid space and check lost does the job for us. I couldn't quite understand entirely what this does, but essentially it maps the positions that we've established on the grid earlier. And as this xy for x in range, if the color is black, it's going to be accepted as a valid position by this list. And you may be wondering, why do we need to have two lists with the same name variable? Well, it's because if I understand it correctly from the YouTube channel, these two are the same, but in the case of the second one, it's just to flatten out the first list, right? Because the first accepted positions list, it's in the form of a list of tuples, because we have this xy, xy this, and xy that, which are tuples, but they're made into a list. So that, I hope that makes sense. And this accepted pose is to get rid of that and just present the xy as a tuple instead of a list instead of establishing the xy as a tuple inside of a list. So it's just let me try to draw it in this. So instead of using it like this, I'm sorry, this x comma y comma a comma b. Here, if we see here, right, there are multiple unneeded lists, right? Let me space this so it's clear. This is a list inside of a list. This is a tuple inside of a list inside of another list. So it's kind of unnecessary, right? And this function is to flatten out or to remove this list and just make it so that the xy and the ab of the position of the valid grid or the valid play area is just a tuple. Hopefully that makes sense. Let's move on to the formatted shape. Formatted shape is the shape that is already converted, and it's probably our current piece that we have right now in play. And it's going to be I couldn't understand this properly, but it's probably going to check if it's in a if the xy of the formatted shape is in an accepted position or not. If it does, if it is in a accepted position, it's going to return as true. If it's not, it's going to return as false. What this means, pos one is essentially to I'm sorry, I couldn't understand it properly either, but uh we have this range, right? We have this range of x's and y's that are into one tuples, and if I try to explain it, explain this and butcher it, I'm sorry, but essentially, if it doesn't belong in this position of accepted position, it's going to return as false, which is this conditional. I hope that makes sense. I know it doesn't, but if I'm wrong, I'm sorry. The YouTube channel explained this a little bit more understandable than I do. So let's move on to the check loss function, which is just the same as this, except that it's going to check if the block is out of board instead of validating if it's on the grid or not. These two are probably these two have probably the same objective, but serves two different functions, because basically searching for the correct play area are made by two different or separate functions, which is check loss and valid, checking for the valid space. This is pretty straightforward, right? Because for the position of x and y, that is for the grid. Uh, if it doesn't if it's less than one, I couldn't understand. I'm sorry, I did not understand this either. I'm trying to I'm trying to collect my thoughts for pause and positions. X, Y, pause. Yes. Oh, this is for the block so that it doesn't fall endlessly to the bottom of the abyss. I'm sorry, because uh, we have this play space, right, that we've established by using the x and y axis, and essentially this function just checks if it's in the bottom or not. Uh, if it's already on the if it's already on the zeroth row or the bottom of the grid, it's going to return as true, and um, it's going to stop the block from falling, and it's going to return as false. This here. I'm sorry. I think I might be wrong here. For pause and positions, x y pause if y less than one. Yes, it's prevented from falling, but and if it's on the bottom, it's going to be directed into the list of positions that are in here. Where is it? In the convert shape format here. So the shape is going to stay at place or stay at a locked position, and here. And that is about the function of check loss. Let's move on to the clear rows. And the clear rows function is the most difficult part that I've tried to understand, but I couldn't quite get it. Let me try to search it. Now this is the clear rows function. I understood this as the original developer trying to essentially cut out the part where we have a clear row, we have a full row full of blocks, and they cut it and they move all of the rows above it to the bottom and add the same number of rows that are deleted that were deleted in the clear or the full row, right? So if that makes sense, the video explained this more beautifully than I do, but essentially that's what it does. I don't understand the increment equals 0 here, but what I do understand is this, because it's kind of pretty simple if you try to see it. For I in range line grid, blah, 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 it's essentially going to check uh, from the bottom. Wait, no, bottom. It's going to check from the bottom of the grid to the top instead of the top to bottom, right? Because uh I don't know I don't know the reason. I couldn't understand the reason, even though the video explained it. I still don't understand it. But it's just checking the grid backwards here, as the comments here stated, and this is going to get the last row or the bottom row and check from there upside to the top row. So the reason is that because it's probably going to move uh, the the row above it first, right? Because we're going to check for the bottom if there are full row from the bottom to the top row. Hopefully that makes sense. I know I couldn't explain it properly, but let's just try to move on and bear with it. And um increment plus equals 1 is just to signal that there are one row that is full, and it got added if there are no zeros in a row. So this conditional is to check if a row is full or not. If there are no black spots in the grid row, then it's going to add the increment the value of 1 uh, to the row itself, which is going to be deleted by this, right? Because in this index equals I is just to signal for index below it so that it doesn't change, and the only thing changed is the row above it. So yeah, that's pretty much it. And this bottom function is just the same as this. It's not actually the same, but it's to complement and to fulfill it entirely. If I explain it in a I'm sorry if I butcher this. If I try to explain this is to check it and to delete it, and this part of the function is to move the above rows to the bottom. Hopefully that makes sense. This is the checking and deleting. This is the moving of the rows and adding one row from the top. That's about it. And let's move on to the draw window function, which is draw window. This function is to draw our canvas with that I've said before as blit, right? Turns out blit is just to establish another element within the canvas that we're going to use. Draw window, on the other hand, with the surface.fill, this is going to make our canvas with black, as you can see here. This is initializing the font and etc. This is to establish our window when we play the game, and which is, first of all, we want to initialize this as Tetris for the title of our game in the top row of our box, right? But before we talk about the position of the title of Tetris, we have to understand that this line of function, which is to access the font path that we're going to use, the size of it, bold, blah blah blah. And the label is just going to be the parameters that is set in this that is going to be set, right? This reason it has Tetris is because it's the title of our game. This is the size of it, and this is the color of it. And we're going to blit it, or we're going to put it on the surface of our game, on the screen of our game, in the position of this top left x plus play with divided by 2, and minus label dot get width uh, divided by 2. This is essentially going to put our title on the center of uh, the play area, or the white rectangle that we've drawn before. This, as the comment suggests, this is for drawing or writing the display of current score. It's going to be like this, pretty straightforward. Last score, label high dot font render high score, label underscore high is to establish the high score. It's going to have a string from the last score, which is the score that is in the file of high score over here. This is going to be explained in the main menu window. I'm going to explain it in just a second. And essentially, this is just the same to establish the where we want to put the label of high score into. So we're going to blit it into this position: start x dot underscore high plus 20, start y high plus 200. That's about it for drawing the gameplay screen, or the display screen, and drawing the content of the grid itself. I couldn't understand this, to be honest with you. This is to, I don't understand. I think this is to draw, this is just the same as the drawing of the gray, gray, what do I say? The gray blocks, or the gray area for the valid space that we're working with. It's essentially the same. Draw grid surface, but the reason we have another one is because in the first one it's correlating to the grid, and it just and it doesn't work for the display, I guess, because I tried to run it without this and it goes into an error. So I tried to follow along the video and put this back here, and the Tetris game went on without any problem. So let's just put this here, and we're going to draw the grid by using this function, draw the grid surface. I think I've already explained this function before, right? And draw grid surface, it essentially uses the function to draw with the parameter of the surface. This already explained before. Now let's move on to the score aspect of the game. There are two main functions that are used in displaying the score and writing another new high score, which is the def update score and the get max score. The difference between these two is update score is writing new high score from the current score that we have, if we have a high score. That's thus making it a conditional with this score that get max score, which is just to read the high score that we have. And yeah, we have it. And speaking of which, I think I need to explain get max score first, because we access the function this here first. Get max score essentially tries to read the text file of high score and read it line by line. Well, in actuality, it only consists of one line and number, and it's going to access it, read it line by line, and return the score that are in the high score as the high score that we have in play. So I hope that makes sense. And after that, we have this function of update score, which is to update our new high score. which is, as you may have probably guessed, if the current score is higher, it's going to write it into the file. If it's not, if new score is this is if the new score is higher than the current score that are in the high score, it's going to write the new score instead. But if the new score is just less than or equal to, then it's just going to access the score as it is without actually changing it. I hope that clears up the score score aspect of the game. Let's try to explain the function of the main window now. Now this main window is just it's a lot, but it's one of the easiest part that I could understand. So let's go through it. The main window function is our main function for the game, or the core of our game. First of all, we have the lock positions in the dictionary that we are going to access with the function that I've already explained before, which is the, if I'm not correct, valid space. I think, yeah, I think it is for the valid space. I forgot a lot, I'm sorry. Locked positions is going to be accessed by create grid, and that's pretty much it. So create grid is going to access this variable. It's going to know which of the positions on the grid that are locked by the pieces of the blocks. So it's going, at first it's going to have a empty dictionary with no keys and values, but as the game goes on, it's going to be fulfilled by the blocks. Then we're going to create the grid using the lock positions that are present in our empty lock positions for now. And we're going to set the change piece run equals to false and true. These two are essentially two main logic that we're going to use in this main, because run equals true is to loop our current program so that it doesn't stop when either we lose or press the X button on the top right corner of the window. And the change piece equals false is to set the logic in here, so that here, if change piece equal, this is set to false, right? Change piece is equals to false. So if it's false, then it's going to be changed. Then it means that the piece is going to be changed as true. Wait, why is it false here? So yeah, this is going to be accessed by our keys here. So change piece equals false is just to prevent the logic from running. Let me try to explain this in a better way. Change piece exemplifies or symbolizes that it is not time to change the piece. So that is why it's set to false. If it's set to true, then it's time to change the piece. I think that's the gist of it. That's the simplest way to explain it. And we're going to have two more variables here with the same amount of function, which is get shape. Current piece is going to set as get shape. It's going to be randomized. Next piece is also going to be randomized, and we're going to set a clock here. Clock with the PyGame function. I don't understand it pretty well. The fall time, fall speed, and level time is going to be set separately. Fall time is just how many ticks per second, I guess. fault time is going to be not set. 0 means it's not set. Fall speed is going to be 0.35 ticks per second. Level time is set to be infinite. Score is set to be 0 for this for the very first gameplay. If we don't have this high score text file, it's okay. It's going to write itself. And we're going to set the last score that is going to be displayed on our gameplay display by accessing the function of getMaxScore. Now let's run the game. While running the game, we're going to create the grid, right? Because first of all, we're going to create the grid, and then this I don't understand because it essentially, I couldn't explain this correctly, but essentially it's going to access the clock that we have here, that we have set up here, to act as a timer on our game, so that, oh yeah, I forgot to mention that in this game, every 5 blocks that we place, it's going to increase the speed. So this clock is kind of increasing the difficulty, or just to it's just to record the game. Clock tick, this is just the tick of the game. Of level time, this is also to increase the difficulty of the game, so that every 10 seconds, as it's stated here, it's going to increase the fall speed, right? From 35, it's going to be added by this, added by it's going to be minus 0.005 from the 0.35 until it hits the top speed of 0.15, which means 0.15 seconds, 0.15 pixels per second, if I'm not wrong. Yep, I think that's it. I mean, it will fall every 0.15 seconds. I think that's it. And the F fall time, blah blah blah, divided by 100 is more than fall speed. This is to, I don't understand this. This is to, oh, this is to check if the block has hit rock bottom or not. If it hits the bottom of the playboard, it's going to stop the falling speed, in the falling time, fall speed, which is set to be 0, right? And also the current piece dot y is going to be added by 1, which means that after the y-axis, it's going to fall over here, then it's going to stop and it's going to move over here instead, and not stay here, so that it's going to stay here. I hope that makes sense. And it's going to change the variable of change piece into true, so that it changes the piece into the next piece that I've already explained before. Now this, for event in PyGame event.get, this is just to map the keys that we're using, right? It's going to map the keys that we're using into whatever it is that we try to map our functions to. For instance, this, if we press key left, it's going to move our block to the left by one axis of x, and if we move it to, using the right arrow key, it's going to move it by 1 to the left, and down, it's going to move it down by 1 point, point of y-axis, and the up key that I've already mentioned before, it's going to rotate the piece, which is here, current piece rotation, current piece dot rotation plus 1, and modulo line current piece shape. This is the same as the piece attribute that we've seen before, because it is essentially the same. It works in the same way, and it has, if not valid space, not valid space, it's going to, I don't understand this either. Probably it's going to scroll through the possible amount of shapes that we have in the list. That's what I could get from the video. This piece position is just a convert shape format, current piece. This is to understand the current piece X and Y that we have. I know it doesn't make any sense, but let's just move on. And for I in range line piece pose, this is to draw the piece on the grid by giving color in the piece location. Oh, this is to replace the black. This is to replace the black by the color of our blocks, right? For instance, if we have an S which has 0 to 255, then it's going to be green. The black block is going, the black square is going to be replaced by a green painted color. This is essentially doing that for us. Now, I've said this before, but the change piece function is works by change piece function works by looking at this code. Let's try to run through it. For pose and piece pose, this is to map the current position into the locked positions that we have, or the positions that are that is unable to be played into because it has a block. It has a block written into it. So change piece works that if it's set to false, if it's set to true, then it's going to map the falling blocks positions, the XY, into the dictionary of locked positions. I mean the dictionary, well, not dictionary here, right? Because it's lists. So yeah, probably it will map the XY into the list of locked positions with the color itself. Oh, no, it actually is the dictionary. So it's going to add to the dictionary of locked positions, and it's going to be mapped in a way that it records all of the set block that are placed on the valid play space. Current piece, next piece, change piece, this is the same. After it's set to true, it's going to be set to false again, so that the falling blocks could fall as intended. The score is going to be calculated if the clear row function is executed. So if it's executed, it's going to add the score by 10. Like how many clear rows in a first in an attempt to place the blocks, it's going to be times 10, and it's going to be added to the score that we have for the current score. Now this is the same as the read or if the get max score and get update score. This is just the same logic behind it. This is a conditional, and this is to draw the window, draw next shape. This is, I've already explained before, this is to execute the function of drawing the window. This is to execute the function of drawing the next shape, and so on and so forth. PyGame.display update is just to display the score and the blocks that we're working with, because it falls every millisecond, and PyGame will update it for us in the display for our game. If check lock positions, this is to check if check loss position is equals to true. Then if it's true, then it's going to stop working, and you're going to lose, or either lose, or you would result in an error. So yeah, and why is that? Because we have two possible positions, right, for the check lost function. First is to check lost if it is above the play area that we've already established, and if it is below the play area, or if it's fallen into the abyss, as I would like to call it. And that's pretty much it. If it changes as false, the boolean variable changes as false, it's going to stop the game, and it's going to it's going to stop at you lost, blah 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 40. This is just to um say that it will display the text you lost with the size of 40 with the color of black in the window. That's why this is draw text middle half the surface of the window. This is going to be updated by the display, and this essentially is just to delay uh delay the Python executables, or the delay Python from reading another code for 200 ticks, which is 2 seconds. And it's going to quit the game for us. And that's pretty much it. That's pretty much the code for the whole game. We also have this last function of def main menu window. This is just to run the game. Run equals true, while run, draw text middle, press any key to begin. We have already established this before. We're going to execute it now, and PyGame will update the screen. And I've added a tiny bit of code in this, as such that if we press the escape key and while in the starting screen, we're going to exit the game. So yeah, that's pretty much the thing that I've added in this game, because I know it seems small, but I think it's pretty crucial because reasons. So yeah, and now we're going to run through this in just a bit. For event and PyGame event get essentially this means that if somehow PyGame quits or we press escape key, the runtime is going to equal to false. This is going to equal to false, and it won't execute anything, and it will just quit. But if you happen to press any key on your keyboard at this time of the function running, it's going to execute the function of main window, which is this that I've already explained just a second before. And that's about it. This is PyGame.quit if the run is equal to true. That's pretty much it. And we're going to run it by using this when displaying the class, when PyGame.display set mode as width as height. This is to set the height, right? So PyGame.display set caption Tetris main menu when this is the starting of the game. That is pretty much the program of Tetris that I've made in this couple of weeks. I hope it could serve well in my grades of algorithm and programming, and I hope it brings a certain amount of new knowledge to the viewers. And that's pretty much that I can share with you all. Thank you for stopping by, and have a good day. Thank you.